Peace and greetings. This is a video journal on this 1UP arcade that we are trying to fix. So come along. Alright, so this is the current setup. As you can see, it's a 4-player arcade system. We have 4 Happ Wico 360 joysticks. Wow. Different arrays of buttons. Then we have this Electric Ice T Trackball. Now, I think these buttons are all supposed to light up, but I'm waiting on an adapter from my client, and then we'll try to power this all with 5 volt. So right now, only the trackball and the buttons work, but the joysticks and the LEDs, I'm pretty sure require 5 volt, which is why he can't really get it working. Here we have a gamepad tester, and you can see I'm using these LED-WIZ. Let's show you the inside real quick. So here is the setup. So it's all pretty much the same. You know, if you were just to look at these 3 components, it's the same multiplied over. So this is the joysticks, and let me see if I could. These are Happ controls, Wico 360. They do not make these anymore, and I'm gonna be honest with you, these are like $300 to $700 a joystick. So I really want to get this working for this guy, because this is also like historic arcade stuff. Over here we have the Electric Ice T Trackball, and this module connects these 3 buttons and the trackball all together. So it'd be cool for like slot machine games and anything else like that. This right here, as you can see, is the LEDs for that. And we have the RGB, and you can see right there, 5 volt. Here we have the buttons, and the basic setup for the buttons is you have the ground wire, power, and then there's these LED strips with this board right here. So here is the main module. This is an LED-WIZ+GP. That is what it's called. Or what's it called, the LED-WIZ. And basically what this is it has 32 GPIOs. Let's see. So you can input a whole bunch of stuff, and then they split it up into sets of 8. So then you can mess with the voltage. So it has a bank voltage select. So you can see 1 through 8, 9 through 16, and so forth. If you want to mess with the voltage. And then it collects all the ground. So you have just all the ground, and then all the 5 volt for the USB. And then it connects from this USB into whatever your connection is. What's important about this is that these should, you know, you're probably, if you have multiple, you're gonna drive them into a USB hub, but you wanna make sure you power it with 5 volt, or at least 5 volt. You know, because the buttons is one thing, but there's no way in heck you're gonna power the bigger things, like the RGB lights and this joystick. So I'm using this cool site, hardwaretester.com, and you can test different things. So I have just these two and this one and the trackball all set up. So if you look at player one, you can see where the buttons are connected to on the module. And then we can go to the trackball. So I'm moving the trackball right now. And then it has its buttons too. I think this is a right click. Yeah. So yeah, that's pretty cool. This would be cool for like slots or something. All right, so that's the first day of trying to fix this. As you can see, we have activity with the buttons. The main things are the joysticks and the LEDs. I just want to see this all glow up and have the joysticks work. And then we'll push it all to the Raspberry Pi and load up RetroPie and hopefully send this back to the guy. But I'm gonna need to find a power source, a 5-volt power source for the USB hub. I think that's honestly the solution, which is kind of silly if that is the solution. I almost was about to wire the joysticks to Raspberry Picos because a lot of joysticks are analog and the Raspberry Pi can't read analog. But it turns out that these joysticks are digital. I think they have a built-in analog to digital converter or something like that. But so it really shouldn't be that much of an issue. Just like how I got the trackball going, I think it's really just a voltage issue. But yeah, going to take a break from this and I'll get back to y'all tomorrow.